So I'm going to sit up here for one more talk here with Tim Sweeney, the CEO of Epic Games, who we just referenced in our talk. Thank you, Tim. So yeah, I managed to catch up with Tim in Shanghai, of all places, this year at the China Joy Show. So that was a very interesting experience. You know, Tim has been making games for decades and game engines as well. He's one of the great graphics gurus of the world. And you mentioned in one of your talks that computers have gotten about 100,000 times more powerful while you've been making games over the decades here. That's pretty interesting.
Yeah, that's right. Yeah, it's quite an amazing transition to go from Apple II was my first computer to what we have now. You know, right now, in my pocket here, I have a device that's 100,000 times faster than my first PC. But you know, we still are largely on the same paradigm we were back 25 years ago. We still have a screen. It's gotten smaller. We still have a keyboard. It's gotten crappier. And we're still in this old-fashioned computing paradigm. And it's a really exciting time right now. I feel like over the next decade, we could see more progress towards the human use of computers than we've seen so far in my lifetime prior.
So I guess it would be interesting to see, say, the console game makers just drive down on realism and make existing sort of console games just much more realistic, get the human faces right and everything right there. But you've also been very excited about VR and AR, and it almost seems like a divergence from the road that you've been driving down in some ways. Why are you so excited about this?
Well, unlike the previous advances where Moore's law has driven incremental improvements, we're really seeing a complete revolution in the human-computer interface. To go from this experience where you're sitting or standing looking at a little monitor to one where you're completely immersed in a realistic experience that combines objects from the real world together with synthesized images, it's going to be completely freeing, and it's going to enable entirely new kinds of applications. I think it's not just a revolution for gaming, but for all forms of human-computer interaction. Architects, industrial designers, users of social networks and chat services are all going to be immersed in this in their daily lives in the future.
Now in Shanghai, I think you said it about 10 years from now, maybe, perfect AR lenses are going to lead us to get rid of screens for tablets, televisions, theaters, and smartphones. And I thought, gosh, those poor glass makers out there, what are they going to do? But you really believe this, I guess.
Yeah, it can be hard to extrapolate through that sort of technological change. This is not Moore's law. This is not just an incremental improvement. Imagine a 4K or let's say an 8K display. They're actually being manufactured now in small quantities, but imagine an 8K display per eye that follows your motion as you look around. Imagine a 120-degree field of view filling your entire field of view, and imagine this miniaturized to the form factor of your Oakley sunglasses. Yeah, so we're not talking about like putting some big-ass helmet on your head. We're talking about a device that could easily reach 1 billion consumers or 5 billion consumers over the course of the next decade. And that's going to be a really freeing experience. It has implications for all forms of software. Any sort of 2D desktop application you're using now will be reinvented wholesale around the capabilities of augmented reality. And games are kind of the easy problem here because we already know how we're going to take a 3D game and translate it to augmented reality. But all of the other aspects of it, imagine social networks and chat, talking person to person over large distances where it looks like you are really there. It's going to change the whole world economy in unpredictable ways.
So what happens with game developers and the game ecosystem? You've, I think, brought up your own sort of feelings about the potential for an indie apocalypse, I guess, and other people are writing about this and saying there's too many indie game developers out there. We got a few million of them. What are we really going to do, and are those folks going to be able to thrive in this world that's coming?
Well, you know, we've gone through several revolutions in the game industry. The most recent one has been the indie mobile revolution, where it became possible again for a couple of people in a few months to create a standalone game. With the move to VR and augmented reality, it's going to be a much harder and more competitive market. You know, everybody's going to need tools to be able to build photorealistic experiences, to scale them up to the kinds of interactions that you're going to expect in a physically realistic game and simulation. You know, they need powerful tools for that. I think it's going to be a real, real competitive market that's going to lead to very, very high quality game experiences surfacing. And this doesn't necessarily mean huge ones. You know, we built this bullet train demo that we showed at Oculus Connect with 12 developers working for 10 weeks. And we created a really awesome but small experience. And I think the initial VR market, since there are only going to be maybe a few million units in the market by the end of 2016, there'll be small experiences, but they will be awesome. And I think we're going to see a move away from the rather simple 2D games that have dominated mobile development for a long time towards very rich 3D experiences with fairly stringent technological requirements.
Now, the app stores for the last couple of years have been dominated by just a few games, and you know, that sort of doesn't bode well for all those indies out there. What would you sort of like to see this market kind of evolve into? Something with more choice, more variety, I guess, right?
Yeah, and you know, the market needs more structure. I think it's absolutely insane that there are over 250,000 games being released in the App Store every year, and they're each built by 2 or 3 people. You know, the average project is very small and has essentially a 1% chance of providing a living wage to its developers. That's a really unfortunate situation. So I think what we need now is a much more stratified ecosystem. We need more large teams producing large, high-quality experiences, and we need the ability for these indie developers to build on top of that. You know, a recent Unreal Engine 4 game that was released was Ark. It sold over 2 million copies on Steam in the first few months. It has a really thriving mod community around it, with mod developers building things on top of it. But the advantage of that is you're building on the shoulders of giants. Instead of 250,000 games competing for top-level visibility, you have, you know, a genre of games with a leading game in it and a mod ecosystem around it. It has a lot more opportunity for developers to be kind of the big fish in the small pond.
So maybe like 100 thriving sub-markets, maybe that.
Yeah, that's the only plausible
for everybody.
Yeah, that's the only plausible way that 1 million developers could earn a living in the game industry. I see there is a real path to that, but there is not a path to 250,000 games somehow being recognized by users.
So as tech gets more powerful, making games on top of that tech could be harder and harder. How do you keep tools simple and making games more accessible still?
Well, Einstein had a maxim on that. He said, keep it as simple as possible, but no simpler than that. And you know, our experience building games is that it's really, really easy to start building a game now. It's an order of magnitude harder to actually ship a game, and it's 3 orders of magnitude harder than that to ship a game that's commercially successful. And so what we do in all of our efforts is optimize for the ultimate outcome of success. You know, building tools that favor being able to build, you know, maintain over a life cycle, scale, debug, ship, and maintain and grow large-scale games. And this necessarily means tools that have a higher, steeper learning curve, you know, than Unity, for example. But it also means tools that are able to, you know, reach these high magnitudes of success with a higher probability. You know, the thing is with Unreal, there are multiple games that have made over $1 billion, you know, in their franchise lifetime with the engine. It's really comes from this high-end console background and has worked its way down to be more usable. And it's an interesting contrast to coming from the other direction.
So maybe what is your update on the game engine wars? You have sort of, with Unreal, come from the AAA on down, and Unity has sort of bubbled up from the bottom on up in mobile, I guess. What's sort of the competitive situation like?
Well, I guess as far as wars go, this is a pretty gentlemanly war. yeah, there are two major engines widely used now. There's Unity and there's Unreal, and both are really thriving. And since we made Unreal free at GDC of this year, in about 7 months now, 1 million users have chosen Unreal. And these are serious developers building serious games. We've been stunned by that growth. And John Riccatello recently announced 1 million monthly active users with Unity. That's amazing that the game industry has progressed to this state compared to a few years ago when it was just the exclusive club of super elite nerds. It's now a much larger market. I think the real war, if there is a war happening, is between game developers striving to reach an audience and get their games noticed. It's far harder for them and their businesses than it is for us, Epic and Unity as engine providers. And it's on us to provide them with all the tools they need to be able to achieve those levels of success and give them every advantage.
So I guess is your approach very different from Unity's as well? I guess C# is sort of your sort of path all the way through, right? That is a very different approach than what Unity is doing.
Yeah, well, the first 3 generations of Unreal, I had the scripting language, Unreal Script, which I designed. And it was a great way to get started with a small engine. With a little bit of coding, you could get a project up and running quickly. But what we found over the years was that didn't scale to a larger system. Let's face it, we have a C++ operating system at the foundation. We have a C++ game engine built on top of that. Unreal is written in C++, Unity is written in C++. And so if you're building your game code in C++, then you have access to the entire technology stack completely unfettered. And the benefits of that, both having full engine source, go to unrealengine.com and you can download the full Unreal source nowadays. Having the full ability to debug and understand the entire technology stack is really, really important once your project reaches a certain scale and complexity, because there are times you need to dig in and figure out what's really happening there. It's a more expert level of development than kind of the sandbox scripting language approach that Unity has now and that we had in the previous generation. But we feel at a certain point it is necessary in scaling, and for that reason we explicitly, I made the decision to kill Unreal Script, my pet programming language, and move to a pure C++ engine.
Do I have to be geekier then to make games on Unreal? Or?
Well, the neat thing about Unreal is there's also this visual programming system called Blueprints, where without writing a single line of code, you can actually build a small indie-scale project. And a number of games have been shipped without any programming whatsoever in Unreal, so that's really neat. But for people who are programmers, to move from a scripting language to C++, it's a learning curve. It's kind of a rite of passage for the industry. You're like, what? I have to allocate and feed all of my memory myself? But there is a certain magic to it. And by writing code in that manner, you have complete access to the entire operating system and game engine. And you have code that can run a factor of 20 times faster than an interpreted scripting language. And when you're aiming at these higher-end experiences, games with lots of objects, VR and AR, where you're trying to run at 90 or 120 frames a second to keep up with the hardware, it's a matter of life or death for your project.
So we had St. Bain up here talking about game engines and how they need to be sort of brought into the modern age, I guess, and that cloud computing and SaaS, enterprise software lessons should be applied to game engines. Does that resonate with you?
Yeah, well, if you look at all the major successful games, they have a very large component running in the cloud that's running game logic and persistent stuff, and then they have a graphics engine that's running on your device, whether it's PC or mobile. And for the foreseeable future, it's going to be that architecture. We've moved an awful lot to the cloud, and still we need to run a lot on the client. There's been a theory that video streaming would power gaming soon, in just a few years, and it's always been in just a few years. And with augmented reality and VR, you're pushing towards a more mobile form factor, and you're pushing a much, much lower latency requirement. On the games, it's pushing the possibility of cloud rendering out even further, and so there's always going to be a client-server separation there, and it's important for the game engine to really be pragmatic about that trade-off.
So as far as your graphics experience goes, when you look at say a modern game with motion captured, body captured, face captured technology these days, what do you notice that can be improved in those images, I guess?
Well, you know, the way that high-end AAA games solve these problems is by brute force application of tens of millions of dollars to motion capture, facial animation, acting. It's a process that works pretty well, actually, if you look at Call of Duty and what's being done with a massive budget. But the problem is it's woefully uneconomical for most developers. And so the real challenge in that area, simulating realistic humans, and many of these other game systems, is not just how to increase the maximum level of quality that is theoretically attainable within the engine, but how to make it as economical as possible to do that. You know, everybody's always going to be under price pressure, budgetary pressure to create great experiences. And so all of the efforts we're making to that end are to make it as straightforward as possible to create these human animations. You know, creating reusable libraries of animations, reusable skeletons, so that with as little work as possible, you can take an existing human, modify it into what you want, and have it largely work.
I love the faces in Sony's Until Dawn game this summer. But as soon as the people moved, the motion of the bodies, that was the part that seemed unrealistic to me. And I guess it's not simply getting the face right, I guess.
Yeah, that's right. So there you get into a problem of simulating human intelligence, because ultimately having a conversation with a game character is going to result in him having to do what a human would do in that situation. It's an extraordinarily difficult problem that nobody really knows the answer to. It's not just like rendering, where, like, you know, if you give us enough computing power, we know the laws of physics. We can simply simulate the flow of light. With intelligence, we still simply don't know the algorithms yet. We can talk about neural nets and deep learning, but nobody really knows how to apply this to something more than just a brute force algorithm. And it's really one of the major problems that we're going to face over the next decade.
So are you optimistic that we're going to get to simulating reality and believable humans?
Yeah, you know, I think that's really the hardest problem we face in the industry. I do believe that within the next decade, everybody's smartphones, desktop computers, and televisions, all of these other computing devices will be replaced with augmented reality devices that are as convenient as glasses. And then that will be a fairly natural incremental transition we'll make over that time period. But I feel like simulating human intelligence is more than a decade out, and that it's a problem that we'll probably be grappling with for the rest of our lifetimes.
And very good. Thank you very much.
Great. Thanks, Ian.